So let's mess around with MongoDB, shall we? So I've already started up my Hadoop desktop sandbox here, and I've connected to it through PuTTY already. So let's go ahead and log into that as Maria_dev. First thing we need to do is install MongoDB, and fortunately, some kind soul was nice enough to make a connector for Ambari for MongoDB. So all we have to do is go get that, and then we can set it up through Ambari very quickly. So first thing I'm going to do is su root, so I have all the permissions I need to actually install things. And you set up your root password earlier in the course. So what we need to do is go to cd/var/lib/ambari-server/resources/stacks. Okay, so if we do an ls here, let's go to HDP, cd HDP, do another ls. And from here, you should see the version of the Hadoop sandbox that you have installed. So for me, that's 2.5. If you installed a newer one, you might see a higher number. So just cd into the one that you're using. For me, I have 2.5 installed. And from there, I'm going to cd into services. Okay, so if we do a pwd to see where we are, you should be inside something that looks like this, where the 2.5 is whatever version of Hortonworks you installed. So varlib ambari server resources stacks HTTP 2.5 services. And this is where we're going to stick in services that Ambari knows about, and we're going to add MongoDB to the list. So some kind soul has actually made a Mongo Ambari connector available on GitHub. All we have to do is grab a copy of it. So to do that, let's say git clone https://github.com/nikunjness. Make sure you spell that right. It's just as hard to spell as it is to say, so double check the typing on that one. /mongo-ambari.git. And there we have it. That came down pretty quickly. Now we need to restart the Ambari service so it sees it and picks it up. Sudo service ambari restart. And that'll take a minute. All right, so now we can go to log into Ambari to actually finish the setup of MongoDB. So I'm going to open up my web browser and go to 127.0.0.1:8080. I'm going to sign in as my admin user because I'm installing stuff. And now I can go down here to Actions and say Add Service, and MongoDB should be in the list. There it is. So we're going to install MongoDB 3.2 here. And we can just, for our purposes, accept all the defaults. We're just going to be setting it up on a single server. No need to customize anything. And a bunch of warnings just saying that, hey, you're running too much stuff for one little virtual machine, but it is what it is. Proceed anyway. And we will finally say, go ahead and deploy it. So at this point, Ambari is installing MongoDB and starting it up, and if we're lucky, it will succeed. Now, while we're waiting for this, I should point out that MongoDB can be pretty picky. You know, if you do shut it down incorrectly, it might not start up again. And I actually got myself into a situation while I was preparing this lecture where I just could not get it reinstalled and running again no matter what I did. So if you end up getting into that sort of a state, what you might have to do is actually delete your virtual image for your virtual machine and reinstall it from the ground up. And go back and set up your root user and your admin account for Ambari and just start from scratch if need be. But this time it worked, so we actually did start up successfully. As long as we're in Ambari, let's hit next and just finish this thing. And complete. So MongoDB is now installed and up and running, and we can start playing with it. So let's do the same thing we did in Cassandra, where we actually copy our users database from the MovieLens dataset into our database and read it back. So the first thing we need to do is make sure that that MovieLens data is loaded into HDFS on our Hadoop system here, so that you probably already have that, but if not, go take care of that now. Go to Files view up here, that will give us a view into our HDFS file system. We're going to go to user, Maria_dev. And if you already have an ML-100K folder, then great. But if not, go ahead and create that, ML-100K. Click into that, and I'm going to upload the u.users file from the MovieLens dataset. u.user. Cool. So now we have everything in place that we need. But the last thing we need is an actual Python Spark script to actually integrate MongoDB with Spark and see what's going on. So first thing we need to do, though, is finish installing stuff for Python. Let's go back to our session here on our server and type in pip install pymongo. This makes sure that all the bindings for Python and MongoDB are in place. All right, so let's take a look at an actual script where we're actually going to use MongoDB for real. So let's take a look at our script here. What we're going to do, again, just like we did with Cassandra, we're going to read in the u.user data file from the MovieLens dataset and write it into MongoDB as a data frame. So we're going to load up u.user, all of our user information from MovieLens, which contains user IDs and every user's age, gender, occupation, and zip code, convert that into a data frame in Spark, and then write that data frame out to MongoDB. And then we're going to read it back and do a little query on it to get back all the teenagers in our user data set. So this code is going to look very familiar. It's almost exactly like the code for Cassandra. The only difference is that we're using a different connector to tie the two together. So the nice thing about Spark is that when you're using data sets and data frames, code often looks the same no matter what you're doing under the hood for integration. So a lot of this code is the same. We start off by creating a Spark session, and we actually don't need any additional configuration at this point. We specify where the Mongo server is later on. We're going to load up the ml-100k/u.user data file from HDFS and call our parse input function to convert that pipe delimited data from each line into a row object. So we end up with a data frame of rows, which is, a data set. And that row is going to contain fields named user_ID, age, gender, occupation, and zip. And these will be translated into fields in each document for MongoDB. So we create a data frame out of that and write it out. So by saying .format com.mongodb.spark.sql.default source, we're saying we want to tie this data set into MongoDB. And as an option, we're going to specify that we're writing to MongoDB. And the MongoDB server we're talking to is on the local host 127.0.0.1 under the MovieLens database and the user's collection name, okay? We're going to append this data into that collection if it already exists. If it doesn't, it will go ahead and create it for us automatically and save that out. So with this one line of code, we're converting this data frame that contains, again, user ID, age, gender, occupation, and zip into a MongoDB that's running on localhost in the MovieLens database and a user's collection. Now let's read it back in and do a query. So to tie that back into Spark, we can load it up with the same syntax. We can say spark.read, again with the same connector source, and the same URI, saying that we're going to be reading it in from MongoDB on 127.0.0.1, MovieLens database, users collection, load that into a data frame. Now keep in mind, again, we're not actually loading the entire contents of that collection in memory here. Spark is smarter than that. Okay, so it's just going to know this is how I connect this data frame back to its underlying implementation on MongoDB. Let's do some Spark SQL here. We'll create a temporary view called users and actually run a SQL command on it from Spark, selecting anyone that's under the age of 20. So we want to get our teenagers back and show the results. So at this point, where we're saying show, Spark's going to say, I'm doing an action. I need to figure out how to actually execute this. And the MongoDB connector is smart enough to push that logic down into MongoDB itself. So what we're not doing is loading this data into Spark locally and then running a query on it. What it's actually doing is figuring out how do I translate this SQL query into a MongoDB query and actually execute that on MongoDB and return the results back from MongoDB. And then when we're done, we stop the session after we see if it works. So let's go ahead and run this. And what we should see is actually saving our users data set into MongoDB and then reading back all the teenagers from MongoDB from Spark. Let's give it a shot. Back to our session here that we have open on the actual machine on our Horton sandbox. Let's see where we are, and we can actually exit out of root at this point. Go back to the Maria Dev account. Let's go to our home directory. Okay. And let's copy in that script. I put it on Amazon S3 for you, so you can actually use wget to get a copy. Just say wget http media.sundog-soft.com/hadoop/mongospark.py. So we have a copy of that script that we just looked at. Take a quick peek. There it is. All right, now to run it, remember that in this version of the Hadoop sandbox, it actually has Spark 1 and Spark 2 installed. We need to tell it to use Spark 2 explicitly. So we'll say export spark _major_version equals 2. And then we can kick it off. So we can say spark-submit -- packages. This tells it where to actually find the code for the MongoDB connector for Spark. That's at org.mongodb.spark : mongo-spark-connector _2.11 : 2.0.0. Now, if you do have a more recent version of the Hortonworks sandbox installed, that might be different for you. The syntax here is that we're saying we want the connector for Scala version 2.11 and Spark version 2.0.0. So if you do have a more recent set of software installed, you might need to change those numbers accordingly. And finally, the actual script itself, and let's see what happens. Cool. So if we scroll up, you can see the actual results here, where we actually did a read back of the information we stored. So remember, we stored our u.users data from each row into a data frame that was mapped then to a MongoDB collection. And then we read that information out of the collection and did a query for teenagers within that data. And this is what we got back. So notice that we have this _ID field that was automatically added by MongoDB. So this is the unique identifier that MongoDB inserted for each row for us. So that comes back as part of the data frame that we retrieved back. So in addition to the age, gender, occupation, user ID, and zip that we wrote in, _ID gets written in automatically as well, and we got that back. And you can see it worked. You know, we actually got back a bunch of teenagers out of our users database. So pretty cool stuff. That wasn't too hard, right? Cool.